Hello, my name is Jessica Adkins, and for my video presentation I will be discussing space colonization. Now, Stephen Hawking said, "I believe that the long-term future of the human race must be in space. It will be difficult enough to avoid disaster on planet Earth in the next 100 years, let alone the next 1,000 or million. The human race shouldn't have all its eggs in one basket or on one planet. Let's hope we can avoid dropping the basket until we have spread the load." I agree with Stephen Hawking on this. There are several reasons why Earth may not be mankind's last home. First is population growth rates. Many scientists believe the Earth can only sustain between 9 and 10 billion people. This is the maximum amount of people the Earth can provide fresh water and food for. In mid-2016, the world population was 7,404,976,783. The average annual population growth rate was 1.07%. It is estimated we will exceed 9 billion people by 2050 and 10 billion by 2100. Based on these numbers, we could expand beyond the Earth's ability to support us in well under a century. The next is global warming. If we continue to release carbon emissions at the current rates, we could see an average global temperature increase by around 4 degrees Celsius by 2100 and 7 degrees Celsius by 2200. As global temperatures increase and sea levels rise, coastal towns will vanish. Ecosystems will change, valuable freshwater sources and farmlands will be threatened, and extreme weather events will become even more extreme. If global temperatures increase by 12 degrees Celsius, half of the Earth's land area will become uninhabitable. And then there's pollution. We have land pollution. In 2010 alone, the average American produced about 4.3 pounds of garbage a day, with a little over half ending up in landfills. That adds up to a little over 125 million tons of trash added to landfills in the U.S. in 1 year. Then there's water pollution. In developing countries, 70% of industrial waste is dumped untreated into waters. In America, we use about 2.2 billion pounds of pesticides a year. A large amount of that ends up in our water supply. And then air pollution. According to a study published by the Environmental Research Letters, more than 2 million people die each year from exposure to air pollution. This is a bit of a personal subject for me because I grew up in a small town in West Virginia founded for chemical plants. In the 1980s and the 1990s, we regularly had leaks that required my family to go in the house, close all the windows and doors, shut off the ventilation system, and hide in the bathroom with no windows until the leak had been contained and the pollutants had dispersed in the air. How much pollution can our planet take before our environment is altered to the point that it no longer supports our existence? And then there's a possibility of a natural disaster. Now, while it is unlikely a natural disaster will occur that can wipe out all life on Earth, it is very possible one could occur that can drastically reduce the maximum population the Earth can support. There are approximately 20 supervolcanoes on Earth. The Earth sees a supervolcano eruption about every 100,000 years. The last one was 74,000 years ago. So there's a very real possibility that in the next 25,000 years or so, we will see another supervolcano eruption. And if a supervolcano erupts, it could cover half a continent in volcanic ash, killing all animals and decimating the crops. Then we have the ever-looming possibility of a giant asteroid. It is believed that a giant asteroid hit the Earth 65 million years ago and caused the extinction of the dinosaurs. In 2028, an asteroid about a mile wide will come close to the Earth, but will miss the planet. If these calculations are incorrect, or if something changes the path of this asteroid and it does hit the Earth, it would wipe out most of the life on our planet. Who knows what astronomers may detect in the future? There may be a giant asteroid racing towards our planet hundreds or thousands of years in the future. And last but not least is solar expansion. When our sun begins its final stages of life, it will expand into a red giant. In about 7.5 billion years, the sun will swallow the Earth, but it will cause the Earth to become uninhabitable long before that. In about 5 billion years, all of Earth's water, oceans and rivers, will have boiled up. Hopefully we're long gone before then. Now we have a few options for where we could possibly colonize here close to home. The first is the moon. NASA has its eye on the Shanklin crater at the moon's south pole as a prime location for a moon colony. There's already water present inside the 130 square mile moon bowl. A series of solar reflectors would be placed at the rim's peaks, reflecting sunlight into the crater. Then solar-powered robots would build the colony. NASA estimates it could complete this job for about $10 billion, which is actually pretty reasonable considering the Apollo program would have cost about $150 billion in today's dollars. Now, some of the benefits of a moon colony is that building our first off-world colony that close would allow us a little bit of trial and error. It would be much cheaper to transport the materials there. And a moon base could act as a refueling station for future space missions, reducing the cost of repeat trips to Mars and elsewhere. Now, some of the problems with living in space, while a moon colony would be beneficial for scientific research and refueling, it is not a suitable alternative to Earth as a long-term home for humanity. Low gravity and increased radiation exposure would prevent long-term settlers from thriving on a moon colony. Extended low or microgravity living reduces bone and muscle mass, and extended exposure to increased radiation has had long-term effects on astronauts' central nervous systems. Procreation in space may be impossible as well. First is the risk of birth defects from increased radiation outside the protection of Earth's atmosphere. Scientists speculate many complications could occur during a pregnancy in low gravity as well. Then there's the idea of free-floating space colonies. It's actually something that scientists in the 1970s were considering, building orbitable space colonies. These colonies would be solar-powered with an endless supply of energy due to the continuous light in orbit. They would be spinning cylinders in order to create their own gravity, which would eliminate some of the problems associated with other types of space colonies as far as low gravity is concerned. But let's face it, living in a floating city above the Earth is not near as grandiose as living on Mars or another planet. And it would be a very costly endeavor. Some people think that we should look at Venus as a second home because of its similar gravity to Earth. But Venus is very inhospitable to humans. We could look at terraforming Venus, but the time and resources it would take might not be worth the benefit, since one of the reasons for seeking an alternative home is the future expansion of the Sun, and Venus is closer to the Sun than the Earth. Another option for colonies on Venus would be free-floating space colonies. But again, would the effort be worth the time and resources required to make this happen when we can do the same thing close to home? And then there's the idea of Mars colonies, which seems to be the most popular right now in our society. Now, building enclosed colonies on Mars faces quite a few challenges. The cost of transporting materials, the 249 million miles to Mars, would be astronomical, estimated at about 10 billion per settler. And the equipment on Mars would become bombarded with thick dust requiring constant maintenance. And Mars' weak gravity and strong radiation could have the same negative health effects that living on the moon could have. So then there's the possibility of terraforming Mars. Well, a full planetary terraforming of Mars would take tens of thousands of years, but it is theoretically possible. And I actually have a short video that I will play. I'm just detailing some of the options and what we can do to terraform Mars. Okay, so while terraforming Mars would be very costly and timely, it is possible, and it could give the human race a home for a few thousand years after the sun expands to heat the Earth beyond our ability to survive. Provided that the solar winds don't blow any atmosphere that we create away due to the reduced gravity on Mars. And then there's the idea of searching other solar systems for habitable planets. Now, the closest star to our solar system is Proxima Centauri, which is 4.24 light years from Earth. Using the fastest existing means of space travel, the gravity assist method, it would take 19,000 years to travel to Proxima Centauri. Over the past few decades, several concepts for nuclear thermal propulsion have been built and tested. While nuclear thermal propulsion is much faster than any current form of space travel, it would still take about 1,000 years to make the 4.24 light-year trip to Proxima Centauri. Now, while the idea of a multi-generational lifeboat traveling through space in search of a new home for mankind is very romantic, the reality is long-term space travel faces the same challenges as colonies on the Moon or Mars. Extended living in low gravity and radiation exposure has many detrimental side effects, including an unlikelihood of procreation. Now, there are several theoretical methods for space travel that could decrease the time needed to travel to another solar system. But unless these theoretical methods become reality, it is out of the realm of our possibility. So for now, our best option for a space colony is our moon. The close location reduces cost and allows for quick travel to and from Earth in the event of an emergency, and to rotate settlers in and out so they're not exposed to the low gravity and radiation for too long. Now, we should seriously consider beginning the terraforming process on Mars in the next couple of decades to provide an alternative home for mankind in the future. And we should also continue to explore the outer reaches of our solar system for the possibility of terraforming and or building colonies on some of the Jehovian planets or their many moons. And we need to continue to research and test alternative forms of powering spacecraft to try and increase travel times. Maybe we will be able to explore distant solar systems and find a habitable planet before our sun dies and us with it. Thanks for watching.